and welcome to Today in Space. We're starting off this month, we're starting off March here of 2020, talking about the balance, because, I don't know, I've been like doing these at the beginning of the month because it gives me a second to just restart and look at the month again. It's helpful for me. I mean, that's how this podcast has always been. This podcast has been a sense of growth for me. I feel like I'm getting better as a person by doing this podcast. It kind of puts me on notice to put it out there and then follow up on it and actually make it happen. And one of the things that I love about talking about science, and it's helped my life, and just trying to spread what I've learned, because I'm a lifetime learner. I'm someone that's here to that's my hobby, is learning and learning how I want to learn, how is best for me, how to get it up here. And this podcast has been great for that. It's allowed me to focus. I've always been really good at focusing on one thing, and this podcast has taken me to another level with this. And getting to this point where we're releasing episodes every week has been great. It's been such a crazy exercise. One of the other things that the podcast did around the 3-year mark for me was I realized that the goals that I was setting were actually very achievable in a lot sooner time than I originally thought. So that kind of got me on the path of saying, well, let me try new things. And one of the things that I tried was 3D printing. And, I had found a 3D printer that was called a RigidBot, and RigidBot Big, and it was a Kickstarter project, and it was right around when everyone was talking about Kickstarters. This is probably 3 or so years ago. We actually started talking about it on this podcast, about me getting a 3D printer and that journey of figuring it out. Because remember, when I started this podcast, I was a young engineer who was still in college, who was already past the 4-year mark, didn't graduate on time, and was a chronic just never finish anything, which is part of the reason why I didn't graduate on time, was because I was trying to do something different than really what college was. I was there to learn and to absorb everything. And the interesting thing about my school is we did things in quarters. So a class that was 14 weeks, a semester, we did them in 7 weeks. And so we had terms. And so it was very, very fast paced. And had I gone to another school, I think I would have learned differently. But the amazing thing that it taught me to do was to learn extremely quickly, to download at a faster rate than I would if I was at a semester course. And it was difficult. I was not prepared. I did not have the baseline stuff, but I learned through doing. And so, and a lot of the classes were very, very theoretical. So it just didn't fit my learning style. Now, 3D printing has been something that has just, I've found it's very hands-on, and at this point, after doing it for about 3 years now, and now actually working in the industry, it's the perfect science for my learning style. And so we started AG3D about 3 years ago, which 2 years ago actually, which was, well, let me backtrack actually first. So I got that RigidBot Big 3D printer because I like to rant a lot here on the podcast, if you haven't noticed already. But bought that 3D printer, figured it out, got it to print. That was one of the most exciting things, is getting that first print to work. Never mind the first layer, because, the most important thing about 3D printing is you're building it on a surface, at least the 3D printing that I use. There are many, many different types of 3D printing. There's even people who are trying to 3D print hearts and organs so that people don't have to necessarily be on a large waiting list. We can actually generate an actual human organ out of the same genetic material using stem cells that person is, so they don't need the rejection medicine potentially, and they can just get it and not need to be on that list when it's a life-saving procedure. Those things are all types of 3D printing. There's also people are building, you may have seen this, houses with giant concrete nozzles that are building these houses in place a lot cheaper than they would be anywhere else, and they're providing homes for people that are in areas where they can't afford the homes in most areas. I know here in the New England area, especially in the Boston area, ever since Boston in the last few years has been getting more and more people here, the city has been growing, and it's a good thing, but the prices of real estate has gone through the roof, even for a small amount of land or room, even a studio apartment. I mean, we're talking like $3,500 a month for a tiny studio apartment in the city. So 3D printing has the ability to change the way that the world around us is in such drastic ways. But I'm always a fan of comparing the technology of 3D printing to, say, the telephone, right? 3D printing in its state today, as miraculous as it is in my opinion where the original phone operators were, right? So the original, when we used to have people on the line taking plugs and connecting lines. Oh, where do you want to call? Okay, we're going to plug you into San Francisco. You're from New York, we're going to plug you in. That's where 3D printing is today. And we haven't even got to the point where we're at the smartphone of 3D printers. And when that happens, man, the world is going to change. And full customization options and a whole change in how things are done. You know, instead of buying something from Amazon, you may be buying material for your 3D printer at home and then purchasing the design files online from other people, from designers, and completely shift the paradigm of how things are bought, from designers going through manufacturers, going through sales outfits and marketers to get products out. They may be able to sell directly to you, and you may be able to manufacture directly in your home. A good sci-fi comparison is the replicator in Star Trek, right? The replicator, you could literally put almost anything in, especially it was almost always food, but you know, we also saw later that people would try and print weapons and other things. Obviously, weapons were blocked out. In most cases, I think in Deep Space Nine, people were able, there was if I remember correctly, but you know, things like that where the future of where things can be, I think, is huge with 3D printing. To go into space, right, if we give the comparison for how 3D printing can affect space, if we are able to 3D print in orbit, which we've already started doing, we've seen that on the International Space Station, we've seen that 3D printing in space is possible, and we saw initial results that, I am paraphrasing here, but the actual adhesion between the different layers that it builds, right, was better in space than it was on Earth, which is great news. Again, preliminary data, only the first data set that we've really ever gotten for that. A company called Made in Space is responsible for this. So with space, if we're able to manufacture in orbit, right, take the ISS example, astronauts now can be more effective, and everyone involved in the mission can be more effective in weight control, which is the whole game of space, right? The heavier your spacecraft is, the more fuel you require, and the stronger rocket that needs to be built and designed to bring that payload into orbit. So building something like the Enterprise from Star Trek is not really possible, because how are you going to launch that up there? What you would have to do in today's world is you'd have to do it like we did with the International Space Station, where the space shuttle was bringing up pieces of the International Space Station, and then we were installing it in space. That's how you would have to manufacture right now for a big spaceship. If we had fusion and we wanted to go to other places and travel the universe and build a spaceship, that's how we'd have to do it today. But if we're able to build that ship or anything else in orbit, have a 3D printer in space building things, the whole game changes. And at that point, we could build things that are much stronger, we can't build a spaceship like we build a submarine right now, because deep ocean and deep space, they're the two extremes of the pressures and the harsh environment that things can contain. Space, obviously no pressure at all, so you have to prevent it from you have to make sure that the pressure is contained, it doesn't release. And in deep sea, you're obviously worrying about the extreme pressures that are exerting on the outside of the spacecraft to the inside, and then the challenge of keeping the pressure inside so that person doesn't become compressed and obviously die. So the amazing thing with 3D printing in orbit is that we could build structures and spacecraft that are extremely, extremely rigid and strong and can sustain the harsh environments of space. We could possibly do that. But even more than that, the cost savings is really where the important thing is. Not so much the capability of the spacecraft we can build, but the amount of money that would be saved compared to today for the amount of launches that you would have to purchase to eventually get that thing into orbit. The only people that have done that is people like NASA, because they have an insane, they have a budget that they could have gone after that when they did that with the space shuttle and the International Space Station. there isn't a company that's going to be able to do that today. The only kind of company that could possibly do that is someone like SpaceX, right? So 3D printing has the ability to change the world. And part of the thing that we do here on the podcast, and something that I'm super passionate about, other than space, is 3D printing. And so if you guys have been following along, we have AG3D. It started off as a service bureau where you can come, and it still is this today, where you can come today if you want something 3D printed. I'm an expert in it. I can help you design the thing that you're actually making. If you have a model yourself, we can just go ahead and start 3D printing it. And I've gotten to the point where I've gotten pretty good at figuring out what it's all about. And so if you want to follow along, we're on AG3D Printing on Instagram. We have all of our projects up there. You can see what we do and learn a little bit about 3D printing just from hanging out and being a part of it. You will learn along the way. And one of the things that we started off doing was just helping other people out. And it slowly became a business, started getting money, and then I actually found myself working in the 3D printing industry, and that has been such an amazing thing in my life, and I wouldn't be there if this podcast didn't exist. This podcast has given me an outlet to gain confidence from the very insecure person that I was in college, and now to this point where I'm actually committing and following through on the things that I want to do. And so that 3D printing business and starting that was amazing. It made money, not quite enough money so that I could do it completely full time. I also didn't really know what I was doing. I'm a scientist, right? I'm an engineer and a musician that got into being an entrepreneur. So there's a lot of things that I've learned about this. And that's kind of what this whole episode is about taking a look at science and what it teaches us about failure. Because before this podcast and this crazy practice of every week putting out an episode and trying to communicate science, it's shown me that failure is so much about the journey, and so many people, including myself in college, tried to avoid it. And then you end up failing by trying to avoid failure. And so if you can focus on what you can do to improve from the failure, seeing it as an opportunity to get better, everything changes. Everything is a completely different world. It's reality, right? It's how you view the world. And that this podcast has helped me view the world in a completely different lens, to the point where I've started, it really blows my mind how much I've gotten out of this podcast. And so we've been growing a lot lately. We've got more people finding the podcast. There's been a lot of great things. We've been at this for about 5 years now. So the hard work is slowly starting to pay off, and we're getting in front of more people. And I love the feedback you guys are giving, so please keep doing that. Now, with AG3D, it slowly became the thing that funded this podcast, because it's not free. It's not this podcast, as much as I can spend my time, it still costs something to put it up there. Not a lot of money, but it does cost to put this podcast out, and AG3D has helped fund this. So it's been this crazy thing where they seem to help each other the same way that 3D printers can 3D print other 3D printers. The podcast helped create AG3D, which then funds Today in Space and lets us do things, and also helps us communicate science, with 3D printing things like the Starship model we have here, the early Starship Starhopper that did its early testing so that it would become the Starship. And we also have, of course, the Crew Dragon that we took with us on our CRS-19 resupply mission with my first rocket launch ever in person. We got to do that thanks to NASA Social. It's all intertwined. It's such a mind. It really is, and I love it. And so one of the things that we started getting into, because we'd like to do more, right? We'd like to do more things with the podcast, and I had to look and see what are people interested? What can AG3D and Today in Space do to provide value for everybody else? Something that I can give and somebody else gets just as much value out of it is 3D printing cosplay items. I mean, we got into it. I've been 3D printing stuff for a while here. I've always wanted to get into that. It was one of those things that I said to myself, wow, wouldn't that be so cool if I could make make a costume and dress up as my favorite characters. I could dress up as Spock. I could dress up as Han Solo. Someone, the Mandalorian, which is something we tried recently. We're going to talk about it in just a sec. All of these things are now possible. And what we're doing with AG3D, we were at PAX East last week, so you may have seen some of that stuff out. One of the things I tried to make for PAX East was the Mandalorian helmet. And again, if you're interested in getting anything cosplay done or anything 3D printed, reach out to us at AG3D Printing on Instagram. Just hit us up in the DMs, or you can email us at ag3d.engineering@gmail.com. Get free quote from doing that. When I worked on this last project, we 3D printed the Mandalorian helmet, or tried to 3D print the Mandalorian helmet. We got a new 3D printer we bought specifically for things like cosplay items. Most 3D printers that are within a good budget, especially for everyday people that may not have a lot of money, they're not a business, maybe they just want to get into it. A lot of the 3D printers that we're using are all 3D printers that anyone who's really looking to get into it has the ability to get into. So they're not super expensive, because there are 3D printers that cost $50,000, $100,000, not money that just normal everyday people can actually get into. But we're talking about 3D printers that are under $1,000. And these are the things that we're using that could produce the quality of stuff that we have here. It's good enough, right? And I think for most people, it's just amazing that you can bring something into reality that wasn't there before, right? And just in a day's time, have something that didn't exist before, right? So that's the magic of what we do here. My typical 3D printer, the Prusa i3 Mark II, which we're upgrading to the 2.5S, so we can get a lot more out of it, a lot of upgrades to features. Prusa's very good with that, Prusa Research. That 3D printer is, about, roughly 12 inches by 10 inches by, 9 inches, roughly, So whatever you can build in that cube is what you're able to print at one time. Now, maybe you're thinking, well, could you just print parts and put them together? Totally. It just takes a little bit more planning. You've got to figure out how you're going to mount them. If you're doing, let's say, holes and bolts and a screw to combine them, you would have to create that in the model and then do that afterwards. Totally possible. But the ability to print the exact size thing that you want in one go is obviously more beneficial for everybody involved. It looks better, it takes less work, and really, once it comes off the 3D printer, it's done, right? So that's the craziness of it. The Mandalorian helmet we tried because it was the kind of the first step. This Creality CR10 S5, which is 500 millimeters by 500 millimeters by 500 millimeters. I don't actually know the conversion here, but I'll do it for you. For the rest of the world, the millimeters make sense. For us in the US, so okay, roughly like 19 and a half inches, right, in all directions. That cube, 19 and a half inch cube, we could fit anything in there. So that's most cosplay stuff, right? That's helmets, that's shoulder, gauntlets, pauldrons, chest pieces. We could make, one of the things that I'd love to make one day is an Iron Man suit. Definitely something I'm going to work on. It's going to take a very long time to get it right. But now it's possible. We have the technology now to actually make that happen. And the cool thing here with the Mandalorian helmet, we tried, you could follow the whole thing. We put it up on our Instagram page at AG3D Printing, but on our TikTok at Today in Space, we also showed the whole progress. And this is the first time one of our videos went viral. So that was a crazy experience. It was cool just to show the progress. It was definitely high stakes. I didn't want it to fail, but it did. And that's okay. And this is where, it's been very busy lately. I've had a lot of anxiety. And one of the things that this podcast has helped me a lot with is how to deal with anxiety, because I was crippled by it for a very long time. It's definitely one of the things that was preventing me from finding what I needed to do to graduate college. There was a lot of anxiety involved. And so 3D printing, this podcast and 3D printing have really helped with so many things, and it's been about mindset. And what science, this podcast, 3D printing has taught me about failure is that if you can look at failure as something that's a challenge, something that's the next thing you got to go after, things change completely. The way that you look at a problem, the way that you look at things not going the way that you want to, go from, man, this sucks, or man, why does this keep happening to me, which was very much my mindset in college, to what went wrong? How do I fix that next time? How can I get better at this? That's been the major moment in my recent life that has been a wild thing. And so when I was posting about this online, I knew it was about explaining the journey. It was about this podcast has been about that. It's about being able to look at, okay, what did we do wrong? How can we do it better? We talk about it a lot here on the podcast. We try to talk about it from just a not as non an objective place as you can be. We talk about it with the balance between SpaceX and NASA and Boeing and the commercial crew program and how the space industry is going, looking at it as this is a problem we can solve. How do we solve it? And that's what this project did for me. When I saw that this had failed, if you guys can see this here, when I saw that the helmet failed, I could have very easily, sorry, the supports are very loud. I could have very easily said, what the I was posting about this online. Now I got to tell people that I failed. Oh my God. It's a very stressful thing, right? That's not really a place most people want to be in. But I didn't think of it that way. I thought of this as this is going to be a cool journey. Whether I succeed, which will be amazing, and everyone will be happy, or I fail, and then it's an opportunity for me to teach people about 3D printing, it's a win-win. And that's what we're going to jump into here. So if we look at it, right? If you saw the video, let's start here from the beginning. If I can teach you one thing about 3D printing today, it's that the first layer that you print is everything. If that first layer doesn't stay down, then while this thing is moving around and printing, it's going to move, and then it's not going to be able to do the high quality. It's not going to know the position, so the nozzle's not going to know where to go. So that first layer is everything. Now, what we did, because this is obviously doesn't have a lot of material to sit on, right? There's this a thing that happens with 3D printing is a thing called warping, right? It's built flat, but then it cools unevenly, and then it starts to rise, right? The different sides start to curl up because the plastic's coming out at 200 degrees Celsius, and it's cooling at air temperature, and it's a lot of heat distribution. So if the plastic isn't cooled properly, it's not going to stay down, especially for something like this that was slated to print for 72 hours, 3 days, which is a long time. Not that long for 3D printing, but it's a long print. And you can see 36 hours, it did really, really well. And then something happened with the bed. Now, the first layer was good. This is what we call a raft. And so this here has the bottom layer. If you guys are just listening to us, I'm going to try my best to visually explain this, but you could check out on video our explanation here so you can actually see the actual part itself. But a raft is basically just a flat layer that's a little bit wider than the support material that's going to be built to hold the part up. Now, in this case, our bottom layer is not flat, right? It's a little bit curved, so we need some support here. Ideally, you'd print with a completely flat surface. You can just build a nice wide surface that sticks really well to the bed. But instead, because we had really thin supports here that were supporting the model, we built this raft that basically giant U underneath the helmet, and there was a little section that held the Mandalorian, the front part of his helmet where his basically where he looks through. That top part overhang had to be supported. And so this first layer went down really well. We actually used glue stick, the same glue stick you used in elementary school to glue paper to paper. That's the same stuff we use to keep, or at least that I use, and a lot of people use on these home 3D printers to keep stuff down. It worked extremely well. I was super happy with that. And the supports built well. And you could see that in the videos. It worked really well. My issue was not the first layer. My issue was that this new 3D printer has a glass bed, right? It's a giant, basically 20-inch square of glass that I printed on. And it's held down to the heated portion of the bed, and the part that moves on the 3D printer, that's held by black paper clips, the little binder clips that have the 2 wire handles that you open up and it clips down. So those flew off at the 36-hour mark, and that's what you're kind of seeing here. So what happened was the helmet was just about to start building the support for that overhang on the helmet, and it shifted. And you can actually see how where this is printed and where this is printed, it shifted over. This happened because that bed lost its clips, and so now I've got a completely smooth glass surface, no friction, sliding back and forth overnight while this thing is printing. So I'm actually very lucky that it turned out this way. I'm very lucky that it only shifted that much. I mean, this could have been a lot worse. I mean, this bed, I look back at the footage, I was doing a time lapse, and you can see this bed moved in so many different directions, but I think it's the adhesion to the plastic, like the nozzle. The plastic coming out of the nozzle was still stuck to the plastic it was putting down on and somehow stayed together. So, again, it's all about mindset. If I had looked at this and said, oh my God, what a failure this is. Why am I doing this? I should be ashamed of myself. I can go, I knew this was tough. I knew this was going to be difficult. Now it's a learning opportunity. Now I can at least share a little bit with everybody. So that is it. That if you can go away with it, it's all about mindset, guys. It really is about. It really is about just how you think about things. So I wanted to share that with you, especially with, we're seeing that today. So I'm recording this a little bit early this week. This is on the Saturday, the end of February here, February 29th. And so if there's any updates, I'll add it to this episode. But basically, the SpaceX was testing their Starship SN1. So this is the first Starship since their test Starship, the Mark 1, blew up during a pressurized test. So basically, you got to think of these spacecraft. A friend of mine told me this recently. It's a really, really good comparison. The spacecraft, especially something like Starship, but spacecraft in general, when they get the fuel put into them, it becomes a pressurized vessel. Now, that may sound super scientific, but basically you're looking at a can of soda, a can of beer, right? A pressurized container. And so, this Starship is a very, very big thing. It's not small, it's not like a can, but even a can, right? When it's pressurized and you get it, you can't just crush it. The inside, the pressurization inside the can prevents you from squeezing it, right? And as soon as you crack it a little bit, or you get a little hole, the whole thing becomes barely strong at all, and it crumbles because it's just thin metal. Starship has sheets of stainless steel that are friction stir welded around each piece to make one giant structure. And this is not necessarily new. This is, this pieces of metal, rolled metal, connected together is how these things are made, how rockets are made. And so it's not a huge, crazy thing that they're doing, but they are testing to see what manufacturing techniques they can do that can hold this pressure, right? Because they've got to load the pressure inside the vehicle to pressurize it so that it can then get ready to launch or do a test fire of the engine, right? And so the first time SpaceX did this with Starship, it didn't go well. It did explode in that pressurization test. Now, this is how SpaceX does things, right? They are so good at this whole thing I was talking about, looking at failure as a learning experience. They've taken it to a whole nother level where even with the original Falcon 1 rocket, and all the way leading up to when they landed their first Falcon 9 on the autonomous drone ship in the middle of the ocean, middle of the Atlantic, that is how they look at things. They look at failure as, look, we're developing something. I want you to fail as fast as possible so that we learn more in a short amount of time, so that way we figure it out by the time we get to a certain point. And that's what they did with Falcon 9. And Falcon 9's revolutionized the rocket industry and dropped the price of what it takes to launch things into orbit. And because it's reusable, right? They not only figured out how to do a rocket that launches successfully, which is amazing, they figured out something that's never been done before, which is recovering it to drop the cost. They're trying to do the same thing with Starship. And it took a while for SpaceX to go from Falcon 1 to Falcon 9 and landing. So this period for SpaceX is going to be a lot of work. They're going to fail. And so with SpaceX basically exploding Starship SN1, they're in the process of that, right? So that's 2 failures right now. I mean, SpaceX had a whole video of all the times that they failed with the Falcon 9, with it blowing up as it's launching, blowing up as it's trying to land. There's a whole compilation video that SpaceX put out about this. We're going to see the same with Starship. So once they figure out how to get the pressurization correct to be strong, they'll start pushing it even further to see how consistent can they be successful. And it's all a game with them. And I love it. And it's something that I've learned from following them and reading more about Elon Musk and just observing what they're doing. And I'm interested to see what the issue was that caused it to rapidly disassemble, as they like to say. I'm wondering if it's really about the technique of the friction stir welding. Like, is that weld on that crease along the spacecraft, is that not strong enough? Are there imperfections that's allowing it to explode, or is it something else entirely? But we're going to find out, and we're going to learn from them. And that's the great thing. SpaceX is going to share, and we're going to learn along the way. So science has taught me a lot about failure and dealing with it and seeing it in a completely different light to make my life better. And so I hope you learned something from this, and I wish you the best with whatever it is that you're working on. If you're going through stuff, I mean, part of the reason why I'm talking about this week was because I was having a hard time the last few weeks, and really was at a really low point when this happened, and it snapped me out of it. It showed me again that no, that's how you're supposed to look at the world, or that's how I like looking at the world, is seeing every failure as an opportunity. And look, we get down. We sometimes we lose our way. Too many things are going on. We're humans. We're not perfect. So something was going on, and I could have freaked out, especially since the video had gone viral before I was done with it, and so I could have seen that as super pressure and crumbled. But like a good spacecraft and a good can of soda, unopened, can of beer, I stayed strong. I went through it and used it as an opportunity to teach. So we will figure it out. We will try again on the Mandalorian Helmet, and we'll bring that to you guys when we can. Follow along on AG3D Printing on Instagram, also Today in Space on TikTok, and we hope you have a good week, everybody. Enjoy yourself, be good to yourself, spread love, and spread science. We'll see you next week.